We talk about stress all the time, right? We know it's bad for us, but what if the very way we measure its damage is, well, just plain wrong? It turns out new research is pointing to a much smarter and way more personal way to see the toll stress is really taking on our bodies.
I mean, think about it. We're always told chronic stress is this silent killer. But how do doctors actually quantify that? Right now, they use this huge battery of tests to get a picture, but what if that whole approach, that wide net they're casting, is actually missing the most important signals?
So, a group of researchers decided to challenge that idea. They dove into this massive data set from a study called Midlife in the United States. And using some pretty powerful new analytical tools, they started hunting for a simpler, more elegant way to measure stress. They had a hunch that a really clear signal was just getting buried in all that noise. And what they found is the real game changer here. It turns out the biological fingerprint that stress leaves on your body isn't a one-size-fits-all kind of thing. Nope, it's deeply personal, and it's shaped by our life experiences in ways we're only just now starting to wrap our heads around. Okay, so to really get what's going on, we first have to talk about the problem with the current method. And it all revolves around this concept called allostatic load. Allostatic load, it sounds complicated, but the idea is actually pretty simple. Think of it like the mileage on your car. It's the cumulative, physiological wear and tear your body goes through from constantly having to adapt to stress. We're not talking about one bad day at work here. We're talking about the slow, grinding effect of months, years, or even decades of pressure. So how do doctors measure this wear and tear today? Well, they use a massive panel of more than 15 different biomarkers. I mean, they test for everything: stress hormones, inflammation, metabolism, your heart health, the whole shebang. It's really comprehensive, but it's also kind of overwhelming, and as we're about to see, maybe not so efficient. And right there, that's the core issue the researchers zeroed in on. The old model is basically a blunt instrument. It just adds up all the scores, assuming that, say, a stress hormone like cortisol carries the same exact weight as an inflammatory marker. But you know what? Biology is almost never that simple or clean. And this is where the hunt for a smarter test really begins. These researchers used some seriously powerful statistical methods to comb through all of that biological data. Their mission? Find the few key biomarkers that were the most predictive of cognitive decline, which is one of the most serious consequences of long-term stress. They had this really elegant three-step approach. First, they used a cool technique from information theory to rank all 15 biomarkers, figuring out which ones provided the most unique, useful information. Step 2, they built what's basically a biological simulator to map out how all these markers talk to each other, because in our bodies, nothing ever acts in a vacuum. And finally, they looked for the absolute smallest group of markers that could still do the predictive work of that entire huge panel. And after all that digging and all that analysis, the result was pretty stunning. It turns out less really is more. You absolutely do not need a giant panel of over 15 tests to see the true signature of stress. And hey, take a look at this. The data is just incredibly concentrated. Just 3 biomarkers: an inflammatory one called IL-6, a metabolic marker called HbA1c, and the hormone DHEAS. They accounted for over 65% of all the predictive power. That basically means the other 12 markers were just adding noise, not clarity. So after all that complex modeling, they finally landed on the magic number. And it was 6. Just 6 biomarkers could not only match the original 15 marker panel, but in some cases actually outperform it. And here they are, the minimal sufficient set. It's this powerful, efficient little signature that combines signals from inflammation, your metabolism, hormones, and your cardiovascular system. But believe it or not, the research didn't stop there. The most amazing discovery was actually still to come. Okay, this is where the story takes a really fascinating turn. The team started to wonder, what if the signature of stress actually changes, depending on a person's life, their circumstances? So they took their data and they split it by socioeconomic status. And the results were just night and day. It was incredible. For people with a lower socioeconomic status, the key stress markers were all pointing to things like hormonal exhaustion and cardiovascular strain, the literal physical toll of chronic adversity. But for people with a higher socioeconomic status, the signature was totally different. It was dominated by metabolic markers, things often linked to lifestyle. And this is the key insight right here. Stress isn't just one biological story. It's written on our bodies in completely different languages, depending on the context of our lives. Now, whenever you get a finding this big, this groundbreaking, you have to ask yourself, okay, is this real, or is it just some weird statistical fluke? Well, the researchers were way ahead of us on that one. They put their new model through an incredibly tough series of stress tests. And guess what? The model held up beautifully. Out of 8 different robustness checks, they tested everything from its stability to how it worked on different groups of people. It passed 7 with flying colors. This wasn't a fluke. This signal is real, and the model is solid. In the researchers' own words, they felt confident that what they found reflects true biological relevance rather than modeling artifacts. In other words, this isn't just a quirk in the math, it's pointing to something real happening in our bodies. So let's bring it all home. What does this all actually mean for the future of our health? Why does a smaller, smarter, and more personal test for stress really matter? Well, the implications are just huge. For doctors and patients, this could mean a 60% cut in lab tests. That makes stress assessment way cheaper, way simpler. And it's not just easier, it's more accurate. But the biggest deal is this. It kicks open the door to a new kind of medicine, one that's context-aware. A medicine that recognizes that to truly understand your health, you have to understand your life. And that leaves us with a really powerful final question to think about. If the biological signature of something as universal as stress is this personal, what other one-size-fits-all ideas in medicine are we getting totally wrong? Where else do we desperately need this kind of personalized upgrade? Thanks for joining me for this explainer.